So we have already derived the equation of state for an adiabatic quasi-static process in terms of the pressure and volume of the gas. So it was PV raised to gamma equal to a constant. As you know, we have to derive two more relationship. So let's go to the second relationship, which connects the temperature and the volume. So that is the second one. So let's have the TV relationship, temperature volume relationship, TV relationship for a quasi-static adiabatic process. Now it's quite simple to start with. You can begin from we can begin from our ideal gas equation, PV equal to nRT. That is the equation to begin with. So we call it some equation number 1 for the time being here, and so therefore I can rewrite Cp equal to, therefore P is equal to, we can write this one is nothing but nRT by V, is it not? nRT by V. So let's call it for the time being equation number 2. Now already you have obtained one relationship. Also we'll go from one relationship to the other. Also PV raised to gamma equal to a constant, that was our relationship, PV raised to gamma equal to a constant. Now what you have to do, we have to substitute for this P using equation number 2. You can understand what is the logic here. We needed a TV relationship, and you have in equation number 3 a PV relationship. So you have to bring temperature here and you have to get rid of pressure from here. So it will become a TV relationship. That is the logic. Okay. For pressure in the സ്ഥാനത്ത് temperature ഇവിടെ വന്നിട്ടുണ്ടെങ്കിൽ നമ്മുടെ relationship temperature volume ആയിട്ട് മാറും. Okay. So that is the logic here. That is why we are substituting equation number 2 here. So what is the fate of the equation becoming? So using 2, is it not? Using equation number 2, what I can do, equation number 3 becomes, so instead of P, what I will write nRT by V. I am substituting for P as nRT by V. Let me show it in a bracket. And we have got V raised to gamma, that's a part of equation number 3, is equal to constant. That is equal to constant. Now can we just simplify this one? You know, in this one, N is a constant, number of moles, R is the universal gas constant, both are constants. So I can take that constant to the other side. So it will be some constant divided by NR, which is a new constant. So what is remaining there now? So what remains there is, like you can write, so here T is there. So therefore T remains there in the numerator. Then there is a V in the denominator and there is a V raised to gamma in the numerator. So what it will become? It will raise to V raised to gamma minus 1. 1 V has to be reduced. That will be equal to some constant divided by, if you want you can just write it, some constant, say C1 divided by NR. So it will be a new constant. So that will be another constant. That will be another constant. Doesn't matter whatever be the constant, that okay. You are getting. So TV raised to gamma minus 1 is equal to constant, and is not your equation. So we got, therefore that is a conclusion for a quasi-static adiabatic process. The temperature volume relationship is TV raised to gamma minus 1 is equal to a constant, and that is our final relationship. You have already used these equations in doing numerical problems, so we just derive it for the time being from first principles. Okay. In the same manner, you can derive the third relationship also. That is also quite simple. So let me derive the third relationship. I can do it here itself, I hope. Okay. So let me go to which is the relationship that is left out. So you have got P, V and t, is it not? All the three variables undergo change during adiabatic process. So first you took PV relationship, which you are given as equation number 3. Now you have done a second case VT relationship, which is given by, let me call this as some equation number 4. Now what is left with? One more relationship should be needed for the remaining pair. That should be a PT relationship. So that is my third case. So the third one is pressure temperature relationship, PT relationship. And you know the logic here. You can do it in multiple ways. I'm just doing one way, that's all. So let's repeat it. See, either you can start from PV raised to gamma equal to a constant, or you can start from TV raised to gamma minus 1 equal to a constant. I think that starting from PV raised to gamma equal to a constant will be better, because there is gamma minus 1 and all in equation number 4. So same logic. Okay, how do we start? I will start from equation number 3, which is PV raised to gamma equal to a constant. Let us look at that one. So it has got a pressure and volume, but I need pressure and temperature. So what should I do? I should replace the volume in terms of the other two. Okay, so I have to rewrite volume. So I will modify equation number 1 in that way. I'm going to substitute for volume. എനിക്ക് വോളിയം നമ്മുടെ റിലേഷനിൽ നിന്ന് ഒഴിവാക്കണം. അപ്പോൾ വോളിയത്തിന് ഒരു സബ്സ്റ്റിറ്റ്യൂഷൻ കൊടുക്കുക എന്നുള്ളതാണല്ലോ അതിൻ്റെ ലോജിക്ക്. അപ്പം ഇക്വേഷൻ നമ്പർ 1 നിന്ന് എനിക്ക് എന്താ കിട്ടുക? സോ ഇക്വേഷൻ നമ്പർ 1 വിൽ ഗിവ് യു, വിച്ച് ഇസ് ഇക്വേഷൻ ഓഫ് സ്റ്റേറ്റ് ഫോർ ഐഡിയൽ ഗ്യാസ്, V is equal to, just a modification, anyone can do this one, nRT by P. So that is where I begin with. Let me say this is equation number 5. You compare this step with equation number 2, where you obtained P. Here you are doing V. That's all. Okay. So if that is the case, what will be equation number 5 becoming? So therefore, equation number 5 will become, it's quite simple. You can do it yourself. So P into V raised to gamma. In place of V, what I will be substituting? I will be substituting nRT by P all raised to gamma equal to a constant. Let me call it as some C, okay, or C1, whatever it is, C1 equal to a constant. So can you now rearrange that one? So what you will do? See here, you know, nr is there. Nr is a constant, and there will be raised to gamma. Gamma is also a constant. We are treating it as a constant here. So nr raised to gamma can be taken out. So what remains is P, then T raised to gamma. Is not what you are getting. So what remains here on the left side is there is P outside the bracket, and gamma is applicable. So T by P. Don't get, see that. T by P raised to gamma will remain there. Is it okay? Is equal to, there was nr raised to gamma is there, C1 divided by some constant divided by nr whole raised to gamma, or n raised to gamma, r raised to gamma, whatever it is. And you know, RHS is, without any doubt, it is some other constant. So let me say that it is some constant C or C2, whatever it is. Now let us modify this equation. How do you modify this equation? You can do it in several ways. Okay, one way of doing is this one. Let me just open up the bracket. It is giving you T raised to gamma, right? T raised to gamma, that is there. And then what is there? You can take in the denominator there is P raised to gamma. Okay, and there is a P there in the numerator. So what will be the thing? Either you can write divided by P raised to gamma minus 1. This is one way of writing it. Several ways you can modify it. T raised to gamma, and I'm taking this, suppose that I'm taking this P to the denominator by this one. So it will be P raised to gamma divided by P. It will be P raised to gamma minus 1. That is equal to a constant. This is one way of writing the result. Okay. Now what other way also you can write? You can also do the other way. Suppose that you are taking this, there is in the denominator P raised to gamma. You take that P raised to gamma to the numerator. So it will become p raised to minus gamma, and there is already one p there. So p into p raised to minus gamma will become p raised to 1 minus gamma. So that is another way of writing. That is t raised to gamma times, what I have done, I have taken p raised to gamma in the denominator to the numerator. So that will be p raised to minus gamma. I'm just doing it like this. You can avoid all these steps. And already there is a p here. There is a p already there in the numerator. So times p, that is some constant c. This is what you're getting. And how do you modify this one? Simply, this is nothing but t raised to gamma. Then both are p, no? Okay, p into p means p raised to 1, you know. So you can just know, is it not? X raised to a into x raised to b equal to x raised to a plus b. So it is minus gamma plus 1 or 1 minus gamma. So it will be equal to p raised to 1 minus gamma. 1 minus gamma equal to a constant, equal to some constant c. Okay, this is another version of the same equation. Okay, you can use any of this equation, that is enough. Well and good that you memorize one of the equations. If you want, you can just again see there are several options. As I told you, you can have another relationship, something like a tp raised to 1 minus gamma by gamma is equal to constant. This relationship is also holding good. Okay, so that's our topic. So we could derive the three relationships for the quasi-static adiabatic process. See that these three relationships are very important as far as we are dealing with quasi-static adiabatic process. Once again, let me remind you, this relationship should not be used when you deal with adiabatic free expansion, which is a fast process. It's applicable only for quasi-static adiabatic processes. Okay, thank you.